So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 230 and in this video we talk about the next functions which we want to implement. It is the insert function and the delete function, but in this video I won't just talk about this function because there is a problem, and in the next video we will implement this function. So what is the problem about insert? So you can see here I have an example linked list. We have a head, here are the nodes 1, 2, 3, and the last node has all-time null PTR. And now my intention is to insert here a new node. So what are the steps for this? So let's start with the right step. First of all, of course, I need to create a new node. Let's say create node. And this create node is very easy actually, because in our function we have already a function here which is creating a new node for us. So I can use that, and we have also the node class which I will use. So this one is very easy. The next step would be to insert this new node, right? Let's write here to insert node. And actually inserting a node in general is also not too difficult. What I mean not too difficult is, let's make here an example. Here is the node which I created. This is the new node, and a node looks like this. And now I decide I want to insert it, for example, here after this node here. So what I do is then I make just a pointer reassignment. What I mean with that is, what I have to do is, because let's say this node I want here at this position, right? Here I want inserted exactly here. So what I do is I get this pointer, let me show you this one, and assign it here. And I get this pointer and assign it here. And that was it. That is just an insert. So so far it's easy. So the insert of coding is very simple. We make just a pointer reassignment. You can see this. So the next step is a problem, because here I showed you not one very important step, which is how to find the right position and how to decide on which side I assign it. So let me write here find right place. So this is a little bit a problem, and that's why I discussed this a little bit ahead. So the point is here, let's make here again. So here I showed you this example where I said I will assign it here. But what is if I wanted not assign it after this node? What is if I wanted assign it before this node? And in our linked list, which we created, we have a little problem. The point is, this pointer here, I can't get, at least not how I programmed it so far. There would be a very easy solution. I just could make here a pointer for every node, which is pointing to the node before. That would be a double linked list, but this is too much work right now, right? Because we have already this linked list and we want not use a double linked list. So this would be a solution, but I don't want it. So another solution is, of course, you can just say, okay, it's also not a big deal, just make a iteration and then all time save the first node and the second node, and when you found the right one, then take just here this first node and the pointer from them and then assign it. So this would work too. And actually we make something similar to this, but the point is I want not make here a new search. And there is again as the last solution which I have is, for example, we have here already a search name single linked list, right? We have created this in our last video. So this one will find my node, which are where I want to go. For example, let's say I want to include here. You can see we have here this list here. And let's say here is this Maggie, and this is on second position. So second position is Maggie. Let's write here. Here's Maggie. And here, here with the search function here, I will find Maggie. In our last video I showed you the search function, and what I want to do now is very simple. In my case I found another solution, is I will modify the search name a little bit, and the only thing what I want modify here is to say this pointer, which is here, well, let me make this another color, this one. So the pointer, this one here, I want saved too. So I will go into my function here later and modify it anyhow before we make the next assignment. So you can see here we make the next assignment, and before I make this one, I want save this in another pointer which I create. So here I will create probably a new pointer, which is the pointer which is, let's call it a pre pointer or something like that, and this will be very important for our decision making later, because like I said, after I designed this pointer here, I can then it's not a big problem, because I find the place where I want, then I decide which way which way I want inserted, left or right. And if I want left, this is the new pointer which I created, and then I use again my insert, which I showed you again. If I have this pointer, I point this one later to this, and then I point this one to this. And you can see this one is also very easy. So we have all time an easy way, but the problem was this pointer is not there in our search function, and I want to not create a new search function, which means I will just modify my my search function which I already have to get access. So that's for the insert, for my plan at least. And you can see this is a random plan. This is not the best solution. This is just a solution which I come up. I don't know even if it works. And there are some points which we have to consider later as well, which is the start point. For example, that I showed you not here, we have to identify the start point, that for example there is only one head, then there will be no assignment of next, which was this here. And then I have to identify there is only the start point, and the head is then automatically my pre-point. But we will discuss these details in the next video and so on. So this was just to get the general problem. And let's go to the next function as well, to the delete. And delete is actually now easy, because now I will use this predefined pointer also in delete, because without this one, it's again, the same problem like before. But let's go to delete. What we do with delete, let's write the steps here. I write the steps here. So first of all, to delete, I create what? I need creating something for delete. I need create a pointer. So create a pointer. And the question is why I need to create a pointer. It's very simple. Let's make it with another color. Let's make this one here this. So you can see, if let's say I want delete now this node Maggie. Till now I want it inserted, find it, and I find this Maggie. The thing what I do is, first of all, I create this pointer. This is this new pointer, and I point and I assign it to this one here, right? You can see this. Oh, let's make it a little bit better, perhaps, that it's not visible. I wrote it over. So I assign it around here. You can see it now. Okay, and then the next step is, again, like here, reassignment. We make a reassignment of pointers. That's it. So the second step, it's very simple, reassignment. Second step, reassignment. Reassignment of pointers. Pointer. And that's almost it. But you can see the reassignment is very simple, not too difficult. What I do is then, here you can see now I have predefined this pointer. You can see I need this if I want us delete it from this here, this left pointer I need anyhow, but I could make it perhaps with this right pointer as well. I'm not sure. Depends. But important is, first we find the node, then I create a pointer, and now I need the left side here and assign this left pointer here, what is here, directly to this one. And how I make this is just very simple. You can see this one is right now not deleted. First I assign this one, and then this pointer is pointing to this one, and then I delete this one. So it's not very difficult. So you can see after we have defined this one pointer here, this pre-pointer, we can make all these reassignments of pointers and there is not a problem. And in this video, there is one more problem which I want to talk, which is related to delete a node, which is an allocation of memory. And you know, our nodes was all time created with the keyword new, right? And the keyword new, let me show you this again. It is this one here. The keyword new is all time, considered to be danger because you must be careful. And when you create the keyword new, you should use all time delete. And in this case, when we delete it, we will use the delete all time because we are now deleting a node and we have to free the memory. Careful, the delete keyword means not you are deleting, you are freeing the memory. So don't make this mistake. Delete keyword means free the memory, not delete the pointer. It's sometimes many make this mistake at start, but that's why I say it. And very important, I showed you a bad practice, which I want to mention here too, which is you can see it here. The bad practice I made here. I even commented very nice, the bad practice. So the bad practice is once I told you when you make a keyword with new, all time use the delete in combination. You have to. So if you see any code which is using a keyword new in a code and has not a delete referenced in a similar anywhere in this code is bad, right? And in my code actually there is no delete keyword. So this is all time. You should be suspicious, right? When you see something there is no delete, that can cause problems. And then I explained to you in our case, in our list here, which I create, there is no problem. And that's not really true, but I will explain you what I mean with that. I said here, in our case, this temp node which we create, so all these nodes here actually, these are all our temporal nodes which we are adding together. We are using them till the end of the program. So my program here in my main is using this till the end. And then this program, what I created here is stopping, right? So this was my assumption when I create this node here. And what is the problem? The problem is, then I wrote here and I explained to you, that is not the, then I said we don't need the word delete because this memory which was allocated will be freed not by us, not by the compiler, not by the C++ what we created, no, by the operating system. And this might be true if you are using perhaps Windows or Linux, the newer ones, but this is the problem. That's not all time true. And what I mean not all time true, there are cases which will be even not freed by the operating system. And that's why I said this here, what I made here is even bad practice. I know the operating system Windows will probably free the memory which I allocate with this program here, because Windows was so programmed to track the memory which was used in this program. With other words, Windows in my case would release all the memory which was here assigned to this program. But in general, this is not the case, and there are cases, special programs which will not free the memory, or let's say operating systems, and they are called the embedded operating system. And what is an embedded operating system, by the way? So the Windows which I use in my system, or Linux, and all this kind of stuff are not embedded operating systems. These are general operating system for PCs. But an embedded system is, for example, when you have a smartwatch, right? The smartwatch has also a program, so this digital smartwatches, right? And they are working also with our operating system, but they are not working with, for example, with Windows or Linux. They have their own operating system, which is specialized only to run the watch functions and not more, because they have not so much resources. They have not so much, they don't need so much functionality. So that would be a waste. And this operating system is called embedded because they built especially only for this purpose, or other embedded operating systems are smartphones, or if you have smart all electric devices which you have who are using controllers. They are all managed by their own operating system. They are not called operating system because they are so small and implement on the most time on the on the chips and so on. But they have a manager, and this management is the operating system, how you can for example use on your electronic devices buttons, and the operating system on these devices will then manage all the inputs, outputs, and this kind of operating systems, they are not necessarily releasing memory. And let's go back to our problem. So this one would work in my Windows program, this one would work in Linux and so on, but this one would not work if you are doing something like I called there is no guarantee. And to cut off, we will now, even if we know that Windows will probably release the memory, the allocated memory here, we will all time use it. Doesn't matter if Windows or whatever it is releasing, it can. We will still use delete actively. What I mean actively is here, not like me here. That is a bad practice. Passively, which means I know, Windows will do the job for me, so I don't have to. No, we will use really the word delete, and then we will delete it. But there was one more reason why I have not used delete, and the next reason is we have not talked about destructor, because this delete here, to delete a list here, we have to explicitly call the destructor. And I said in one of my other videos, normally you don't call a destructor. The destructor is called by the compiler automatically, and will then do his job, which means free the variables and all this kind of stuff. But in this case, we have to call this, and I will show you also, not in the next video, because in the next video we'll talk about insert and delete, but then I will show you how to call the destructor to free the memory actively, and we have to do it all time now. Okay, so the last rule is very simple. When you see new, just use delete. Doesn't matter if you know it will be freed in another way, just you have to use delete when it goes out of scope. But make not the mistake, just create one and then delete it immediately. No, you delete it all time when it goes out of scope. In my example here, when I create the list, then I don't delete it immediately. I wait till here in my main function. You can see my main is here. Here I created this memory, and anywhere here will go out. Before it goes here, perhaps out of this here, when before we exit the program, I will call this delete anyhow, so that it frees this memory. And you can see what I did was just go out of the program, and Windows will handle this perfect. Now this is bad practice, and yeah, for that we need destructor, talking about a destructor a little bit. And yeah, that's it for this video. So, and in the next video we will implement all this kind of stuff. Alright, with that said, I hope you already tried your own implementation for insert and delete. It's not too difficult. Try it, even if it's not perfect. You see, my code will also not be perfect. That's not the case here. That's not important here. We are not making perfect solutions. We are trying to code something and learn something and prototype something. And to make it perfect, you have any way to optimize it, and so on. But yeah, with that said, if you have any questions, any comments which you want ask, write it all time in the comment section. See you in the next video where we start with the implementation. Bye, good luck, and like all time, have fun and never give up.